Very good morning, students. Myself, Praveen, I'm mathematics lecturer. In the last class, we have started a new chapter, that is applications of derivatives. Today is the second class of application of derivatives. In first class, we have discussed the basic concept of application of derivative, where we are applying this derivative. Okay, what are the concept that we are discussing in this application of derivative? Everything we have discussed yesterday, and we have started example solving, and we have solved two problems. We have solved two problems yesterday. Today we will continue with the problems. This is the third problem. The total cost C of x in rupees associated with the production of x units of an item is given by C of x equal to 0.005 x cube minus 0.02 x square plus 30x plus 5000. Find the marginal cost when 5 units are produced. We are finding the marginal cost of that cost function, and that is given C of x equal to given 0.005 x cube minus 0.02 x square plus 30x plus 5000. This is given. We are finding the marginal cost. Okay, we are finding the marginal cost. Then the derivative of this cost function become the marginal cost here. Okay, in this, what is x represent? X represent the number of item that is produced. Okay, then differentiation of 0.005 x cube. This 0.005 is, as it is, x cube derivative is 3x square. X cube derivative 3x square means this power 3 is multiplied to this coefficient. 5 3 z, this is 15. This becomes 0.015 x square minus this x square derivative is 2x. 2 is multiplied to this coefficient. This becomes 0.04x plus 30x derivative is 30 and 5000 derivative is 0. Okay, 5000 derivative is 0. Now this is the derivative. So we are finding the amount of marginal cost. Okay, when the 5 units are produced here, if you take x equal to 5 in this become c dash of 5 is equal to 0.015 into 5 square. 5 square is 25 minus 0.04 into 5 plus 30. This is equal to 25 15s. 25 15s, 25 10s is 250, and 25 5s is 125. The sum of these two is 25 15s. That is equal to 375. 0.375 minus 0.04 into 5. 5 for the 20, that is 0.20 plus 30. From this 0.375, if we subtract 0.20, this becomes 0.175 plus 30, and this becomes 30.175. 30.175 rupees. So this is what the marginal cost of the function when 5 units are produced. When 5 units are produced. When 5 units are produced. So we are checking this option. What is asking here? Approximate value of the marginal cost. Here 30.175 is the answer. Then the nearest value is 30. Nearest value is 30, and the fourth option is correct. Understood now? If we differentiate the cost price, if we differentiate this cost price, we will get the marginal cost. And here 5 units are produced. After derivative, we are substituting the value of x equal to 5. then we have calculated the marginal cost when 5 units are produced. For example, we are producing this kind of items. Okay, we are producing this kind of items, and what is this cost price function? Cost price function is 0.005 x cube minus 0.02 x square plus 30x plus 5000. This is the cost price. We require to find the marginal cost of this pen, and when the 5 pens are produced. So first we have differentiated. This become the marginal price or marginal cost function, and substituting x equal to 5 in this, then we will get a marginal cost of 5 pence. Okay, suppose the 10 pence are produced, then you take x equal to 5 after x equal to 10 after derivative. So we can find the marginal cost of any number of items is produced. Okay, let us move to the next problem. The function f of x equal to x cube minus 3x square plus 4x, x is belong to R, is increasing or decreasing, or neither increasing nor decreasing, none of this. We have given a function and we are checking which kind of function it is. Okay, whether it is increasing function or decreasing function, or neither increasing nor decreasing, or none of this. Let what is the function f of x equal to, that is x cube minus 3x square plus 4x. Differentiating this function f dash of x, that f dash of x, so we are not finding in the interval here. Interval is given na. Okay, so I am taking here x common from this. I am taking x common from this expression. This become x square minus 3x plus 4. Okay, this is a polynomial function. I am simplifying this polynomial function. Here we have given interval. To find the interval in which the given function is increasing or decreasing, so we have to differentiate that. Interval is given here, x belong to R. So I am simplifying this. I have taken x common from all the three terms. Then remain is x square minus 3x plus 4. X square minus 3x plus 4. If we split this, this become x into x square minus 4 minus 3x. On factorizing this, we will get can we factorize this? X square minus 3x throughout its domain. Okay, we are getting this. Let us differentiate this function. X cube is 3x square, x cube is 3x square minus 3x square derivative is 6x and plus 4, and plus 4x derivative is plus 4. Okay, we have given x belong to R, and checking what is it derivative, whether derivative we are getting positive or negative. You know, derivative is positive, there exists what minimum value, and if it is negative, there exists maximum value, or if derivative is 0, then there is a extreme point is existing here. So first we have differentiated this function 3x square minus 6x plus 4. This is a derivative f dash of ex, and I'm splitting this as a 3x square minus 6x plus 4. I'm writing as a 3 plus 1. Okay, and 3 is common. This become x square minus 2x plus 1 plus 1. And this is what x minus 1 whole square, x square minus 2x plus 1 is x minus 1 whole square plus 1. And this value is always positive. This value is always positive. If the derivative is positive, then it is increasing function. The derivative is positive, then it is increasing function. So therefore, f is increasing function. As x value increase, the function value also goes on increase. So it means that the given function is increasing function. So there is one more test called a second derivative test. The second derivative says that if second derivative is positive, there exists minimum value. Okay, second derivative is negative, then there exists maximum value. Okay, so here by the first derivative test, we are getting that the first derivative is always positive. If the first derivative is positive, then it is increasing function. Okay, so let us move to the next problem. The f of x is equal to cos x in the interval 0 comma 2 pi is, we have given a function f of x equal to cos x. In this interval, in this given interval, we have to check whether it is increasing, decreasing, neither increasing nor decreasing, and none of this. Okay, so what is the function here? F of x is equal to cos x. Then f dash of x equal to minus sin x. In this interval pi to 2 pi, if this derivative is positive, then it is increasing function. If this first derivative is negative, then it is a decreasing function. Okay, so let us check by substituting that pi to 2 pi any one of the angle. Okay, at pi to 2 pi, this is what third quadrant and fourth quadrant. Pi to 2 pi. Okay, this is 0, 90 degree, 180 degree, 270 and 360. Here pi to 2 pi is a third and fourth quadrant, and a fourth quadrant. In third quadrant and fourth quadrant, sign value is always negative. What is sign value? Always negative in the third and fourth quadrant. Already here we have minus symbol, and sin x is negative in the third and fourth quadrant. Minus into minus, it become plus, and its value is greater than or equal to 0. Okay, sin here derivative is minus and sin value is minus in the interval pi to 2 pi. So minus into minus, this become plus. Plus means greater than 0. Therefore f is increasing. F is increasing function. F is increasing function in the pi to 2 pi interval. Understood? The same method that we have applied in the last problem, third problem. Okay, na? So first derivative is positive, that's why it is increasing function. Let us move to the next problem. The intervals in which the function f given by f of x equal to x square minus 4x plus 6 is decreasing. We are finding a interval in the in this function. We are finding the interval in which the given function is decreasing. Okay, let us find or let us take the function f of x here. What is f of x? F of x is x square minus 4x plus 2. Finding its derivative is 2x minus 4 x square derivative 2x minus 4x derivative is minus 4 plus 2 derivative 0, leave it. Okay, on taking this derivative equal to 0, we will get a critical point and we will get x is equal to 2 here. If you take 2x minus 4 equal to 0, that this become 2x is equal to 4 and x is equal to 4 by 2 is 2. The critical point is x equal to 2. At this point, the curve is increasing or stopping or decreasing, or it is stopping. It is stopping at x equal to 2. Okay na? So uh, we are checking in which interval it is decreasing. Okay, it is decreasing in which interval that we have to find. If we take here uh, uh, a number line on which the point 2 is lying and left side is minus infinity and right side is plus infinity, then there are two intervals. One is minus infinity to 2 and second one is 2 to infinity. In these two interval, in one interval the given function is increasing function, in another interval it is decreasing function. So we have to check which in which interval it is increasing or in which interval it is decreasing. So let us take interval, the first interval, that is minus infinity to 2, and we are checking here sign of f dash of x, and lastly we are writing the nature of the function, f of x. Here this is f dash of x. In this f dash of x, we are substituting a value which is in this minus infinity to 2 interval. So behind 2 we have a 1, 0, minus 1, minus 2, minus 3. So I am substituting 1 in this f dash of x. This become f dash of 1 equal to 2 into 1 minus 4. This value is minus 2 and it is less than 0. The given function is decreasing function in this interval. If we take another interval 2 to infinity, then yes, we are substituting x value which is in this interval. After 2 we get the 3 and substituting x equal to 3 in this derivative, this become 2 into 3 minus 4, it is equal to 6 minus 4, 2 plus 2, then it is increasing positive, then it is increasing function. What is our question? In which interval it is decreasing? It is in minus infinity to 2. Mean the third option is correct. The same question is asking, if he is asking in which interval it is increasing, then we have to take 2 comma infinity, that is first option is correct. But is asking decreasing na, so is asking decreasing, then it is decreasing in the interval minus infinity to 2. Okay, to find the interval, first to differentiate the function and take the derivative equal to 0, we will get the critical point. Okay, means the given function is decreasing in the first interval and increasing in the second interval, and this curve is like this. Okay, from minus infinity to 2 it is decreasing and 2 to infinity it is increasing. Understood na? So this kind of curve it is. So we need to find in which interval it is decreasing. So minus infinity to 2 it is decreasing function. Clear? Okay. So let us move to the next problem. Is find the slope of the tangent to the curve y is equal to x cube minus x at x is equal to 2. We are finding the slope of the tangent. What is the slope of the tangent formula? Dy by dx. We have given a curve equation is y is equal to x cube minus x. Differentiating this function we are differentiating and substituting at x. We are substituting x equal to 2 in the derivative. Then what is dy by dx? Dy by dx is equal to x cube derivative 3x square minus x derivative 1. At x equal to 2, the slope of the tangent is dy by dx, and it is equal to 3 into 2 square minus 1. 2 square is 4, 4 3 is a 12, 12 minus 1 is 11. Means the slope of the tangent to the curve is 11. Where is the answer? The third option. The third option is the correct option. Okay. So to find the slope of the tangent, we are differentiating the given function and substituting the value of x in the derivative. The resulting is the slope of the tangent at x equal to 2. Next, let us move to the next problem. Find the point at which the tangent to the curve y equal to under root 4x minus 3 minus 1 has its slope is 2 by 3. We are finding uh, find the point. We are finding a point in which the tangent to the curve, this curve is what it is, 2 by 3. Slope is 2 by 3. So let us take the given function y. Y is equals to under root 4x minus 3 minus 1. And is given that dy by dx. Slope is given, that is 2 by 3. It is here slope 2 by 3. Okay. For differentiating this function and taking its value equal to 2 by 3, we will get the point here. Okay. So derivative dy by dx is equal to root derivative is 1 by 2 root 4x minus 3. This is only under root derivative. And inside the root we have 4x minus 3. By the chain rule, 4x minus 3 derivative become 4. Minus 1 derivative is 0. 2 ones are 2 twos are, this is cancel. Next, dy by dx value is given 2 by 3. Then we are taking this is 2 by 3 and it is equal to 2 divided by under root 4x minus 3. This 2 get cancel. So what is remaining here? That is 3 is equal to under root 4x minus 3. 3 is equal to under root 4x minus 3. On squaring both sides, this become 9 is equal to 4x minus 3. And minus 3 taking to LHS, it become plus 3. What is 9 plus 3? 12. 12 is equal to 4x. And into 4 taking to LHS, 12 by 4, it is equal to 3. X is equal to 3. X is equals to 3. So if we take x is equal to 3, x is equal to 3, we have 4 options. In these 4 options, here we have x equal to 2, mean this is wrong answer. Here we have x equal to 2, this is wrong answer. We are getting x equal to 3 here. We are getting here x equal to 3, and here in the second option x equal to we have 5, this is wrong answer. And in the fourth option we have x equal to 3, then this is right answer. In this point, the tangent to the curve has its slope is 2 by 3, that is 3 comma 2. If you put x equal to 3 here, if we substitute here x equal to 3, this become 4 3 is a 12. 12 minus 3, 9. Root 9 is 3. 3 minus 1, 2. Y is equal to 2. X equal to 3. Y is equal to 2. This is the fourth option is the right option. Okay. So in this way, we are calculating the value value of the point. Understood now? Okay. So let us move to the next problem. This is a little bit interesting problem. We are forming equation of tangent. We are forming a equation of tangent to the curve given by x is equal to a sin cube t and y equal to b cos cube t at a point where x t is equal to pi by 2. At the point t equal to pi by 2, we are finding equation of the tangent. So let us take the curve equation, that is x equal to given, yet that is a sine cube t, and y function is given, that is b cos cube t. X equal to a sin cube t, y equal to b cos cube t. At t is equal to pi by 2, then x value become sin pi by 2 value 1. 1 cube is 1, 1 into a. X value is a, and here y value cos 90 is 0, 0 into b is 0, then y is equal to 0. The tangent is drawn at the point a comma 0. The tangent to the curve is drawn at the point a comma 0. Now let us find the slope of the tangent. If we know the point and the slope of the tangent, then we can find the equation of the tangent. So dy by dx is equal to, dy by dx is the slope of the tangent. Dy by dx equal to dy by dt divided by dx by dt. Means we are differentiating this y function with respect to t and dividing this derivative of x with respect to t. So y derivative is b as it is, cos cube t derivative 3 cos square t, and cos t derivative is minus sin t. This is dy by dt divided by dx by dt. Differentiating this a sin cube t. I'm writing as it is, sin cube power 3 derivative 3 sin square t, and sin t derivative is cos t. We applied here chain rule. First we are differentiating to the power, then we are differentiating to the base. Okay, in both cases y and x. So here this 3 cancel, and 1 cos t cancel, 1 sin t cancel, remaining is minus b by a, and 1 cos t divided by sin t remain. This become cot t. Cot t. Now we know the slope of the tangent, a point a comma 0. Then we are forming equation of tangent. Formula is y minus y1 is equal to m into x minus x1. Okay, and this dy by dx at t is equal to pi by 2. This become dy by dx is equal to uh, cot pi by 2. Cot pi by 2 is 0. 0 into minus b by a is 0, and this is nothing but the m. Y minus y1 is 0, m value 0 into x minus x1 is a. The 0 into anything 0, this become y is equal to 0 is the equation of tangent. What is the equation of tangent? Y is equal to 0. You can see that the second option is correct. Understood? To find the equation of tangent, first we require a point from which point we are drawing a tangent. On taking t is equal to pi by 2 in the both equation x equal to and y equal to, we will get a point on the curve x1 y1. Okay, so at t equal to pi by 2, sin pi by 2 is 1, 1 cube is 1, 1 into a is a, and here cos pi by 2 is 0, 0 cube is 0, 0 into b is 0. From this a comma 0 we are drawing a tangent. This is the point. Okay, next we required the slope of the tangent. Here m value we required. If you know the slope and point, then we can form equation of tangent here. So dy by dx is dy by dt divided by dx by dt. We have differentiated both of them with respect to t and divided. On dividing, we have got minus b by a cos t, and the slope of the tangent at t equal to pi by 2, cot pi by 2 is 0, 0 into minus b by 0, and dy by dx become 0. dy by dx is how much? 0. Now the equation of tangent is y minus y1 equal to m into x minus x1. y1 is 0, x1 is a. So y minus y1 is 0, m value slope is 0, x minus x1 is a. 0 into anything is 0, RHS completely 0, in the LHS remaining only y. So y equal to 0 is the equation of the tangent. Clear? Let us move to the next problem. Find the approximate change in the volume V of a cube of side x meters caused by increasing the side by 2%. Okay, we have a cube. We have a cube with a side x centimeter. Let side of cube is equal to x centimeter. Now we have increased the side by 2%. If we increased side by 2%, then how many percent or what percent of volume or approximate change in the volume V of a cube that we have to calculate. Okay, how much the volume increases that we have to find. If side of a cube is x, then volume V is equal to x cube. Volume V equals to x cube. Okay. If side increased, if the side increased by 2%, then 2% means 2 divided by 100 of x. 2x by 100. Increased by 2x by 100, and then the total length of the side of a cube, this become x plus 2 by 100 x, 2 by 100 x. 100 plus 2, 200, 100 plus 2 is 102. 102 x by 100. Now the volume of the new cube become V is equals to 102 x by 100 whole cube. Approximate change in the volume, approximate change in the volume. Okay, increased by 2%. Okay, let us solve in different manner. Increased by 2% means this is 2x by 100, that is dx by dt. Here dv by dt, dv approximate change in the volume is dv is equal to 3x square into dx by dt. This become 3 into x square. Dx by dt is, that is 2x by 100, and this become 3 to the 6 by 100 into x square into x is x cube. This becomes 6 by 100. The previous volume is x cube. After differentiation, this volume changing by 6 by 100. 6 by 100 means 0.06 it is 0.06 x cube. Then how much the volume increased here? 0.6 of the previous volume. The second option is correct. So this is a simple way. First we are considering a side of a cube is x centimeter, the volume become x cube. If the side increased by 2%, means 2 by 100 of the given side x, then this become dx by dt, because x is changed. How much changed? 2% is changed. So that become 2x by 100. Then volume V is equal to x cube, then its derivative. This is dv by dt, that is dv by dt is equal to 3x square into dx by dt. 3x square into dx by dt. Here dx by dt value is 2x by 100 substituted here. This become 3 to the 6 by 100 and x square into x become x cube. This x cube is the given volume. Now the resulting volume is 0.006 x cube, means 0.06 times the volume increases here. Understood? If 2% is increased, then the volume increased by the cube is 0.06 times. Next. A balloon which is always remains spherical has a variable diameter 3 by 2 into 2x plus 1. Find the rate of change of its volume with respect to x. We are finding the rate of change of volume of this spherical balloon with respect to x. What is given here is given that variable diameter. This is diameter. Diameter d is equal to given, that is 3 by 2 into 2x plus 1. 3 by 2 into 2x plus 1. This implies radius become 3 by 2 divided by 2, that become 3 by 4 2x plus 1. Then what is the volume of volume of sphere formula? Volume of sphere is 4 by 3 pi r cube. On differentiating this we get dv by dx, not dv by dx, we have to substitute r value now. 4 by 3 pi r cube, this become 4 by 3 pi r. R value is 3 by 4 into 2x plus 1 whole cube. This is v is equal to 4 by 3 pi, 3 cube is 27 and 4 cube is 64 into 2x plus 1 whole cube. 3x plus 2x plus 1 whole cube it is. Then we are simplifying this. 4 ones are 4 16s are 3 ones are 3 9s are. The value become, volume become, that is 9 pi by 16 into 2x plus 1 whole cube. Now differentiating this, we will get the rate of change of volume, that is dv by dx is equal to 9 pi by 10 into 2x plus 1 whole cube is 3 into 2x plus 1 whole square, and this is the power derivative, and 2x plus 1 derivative is 2, 2 ones are 2 5s are, this become 9 3s are 27, 27 by 5 into 2x plus 1 whole square. This is 10. No, this is not 10, this is actually 16. 16 means 2 ones are 2 8s are it is. This is 2 8s are 27 by 8. dv by dx is how much? 27 by 8 2x plus 1. 27 by 8 pi 2x plus 1 whole square. 27 pi by 8 2x plus 1 whole square. The first option is correct. Understood? So first we have taken diameter is 3 by 2 into 2x plus 1 and radius become half of the diameter, that is 3 by 4 2x plus 1. Substituted this r value in the volume of sphere, because balloon is remains spherical, means that is in the form of sphere. Then substituted r value is 3 by 4 2x plus 1 and cubed will get 3 cube is 27, 4 cube is 64 and into 2x plus 1 whole cube. 4 ones are 4 16s are, 3 ones are 3 9s are, this become 9 by 16 pi. 9 by 16 pi 2x plus 1 whole cube. We required the rate of change of its volume, mean differentiating this function with respect to x. 9 pi by 16 as it is, whole cube derivative 3 into 2x plus 1 whole square, and 2x plus 1 derivative is 2, 2 ones are 2 8s are 16, remaining is 9 3s are 27 pi by 8, 27 pi by 8, and this bracket is 2x plus 1 whole square remaining. Okay. So in this way we are solving this kind of problems. Okay students, you scroll this video slowly and understand the concept what I have explained by solving these problems. So you come to know how to solve this kind of problems. Okay, student, today we will stop here. In the next class, I will come with more problems. Okay, so you go through all these questions and try to solve more problems. Definitely, you will get a good marks in the CUT examination. Okay, students, we'll meet in the next class. Thank you.